All right, Mattie, it looks like you're doing two different types of problems. You're doing area either underneath one curve or area in between two curves, and then you're doing some volume problems. So let's first talk about if it asks you to find area. If it asks you to find area underneath one curve, you typically have something that looks like this. You have a curve, you have a starting point, an ending point, and you want to find the area underneath that curve from the starting point to the ending point. So what we would do is we would integrate. We would add up an infinite number of rectangles underneath that curve to find the area. We were going to integrate it from A to B, the starting point to the ending point of the function, right? If they ask you to find the area between two curves, though, you've got to do a few other things. The first thing you have to do is figure out where they intersect, because you can see on this picture, different functions can intersect at different places. So then the areas could change because the top function could change to the bottom function and so on. So you first have to find the intersection, which means you're going to take the two equations and you're going to set them equal to each other so you can find out where they intersect. Once you have those intersection points, then you can test intervals. You could figure out when they intersect, or in between where they intersect, which function is the top function and which function is the bottom function, by taking a number in that interval, plugging it into both functions, and figuring out which number is higher. That will be your top function. The number that's lower is going to be your bottom function. You want to figure out in each interval which function is above and which function is below. That will help you with step number 3, which is setting up the integrals. You're going to integrate then from A to B of your top minus bottom, but then you're also going to possibly set up another integral from B to C of top minus bottom. Because you can see in my picture, if this is A, this is B, and this is C, from A to B, function f of x is on the top and g of x is on the bottom. So I would integrate it from A to B of f minus g. But from B to C, g is the top function now, and f is the bottom function. So I would integrate from B to C of g minus f. So it switches a little bit. So those are the two kind of things that we need to think about. Are we doing one curve or two curve? If we're doing two curves, then we need to make sure that we follow those 3 steps. So let me do a few problems on your review that talk about area first, and then we'll go back and talk about volume. So it looks like number 1, number 2, both have to deal with area, and then later on number 10 and number 15, and we'll talk about that when we look at the calculator. But if you look at number 1, it asks you to find the area in between two curves. So I know then, because I'm doing area between two curves, I've got to follow those 3 steps. I've got to figure out what the intersection is, I've got to figure out what my intervals are and who's on top versus bottom in each of those intervals, and then I might have to set up multiple different integrals. So on number 1, those are my 2 functions, f of x and g of x. To first figure out what their intersections are, we want to take those 2 functions and set them equal to each other, so that's what I did. I moved every term to the same side, and I ended up getting 3x cubed minus 12x equals 0. I factored with a GCF of 3x, and then I set each part equal to 0. And it looks like they intersect then at 3 different places, at 0, at -2, and at +2. So you can look at the picture of the graph, which you did a good picture on the one that you sent me. Or what you could do is just kind of do a number line. I know that they intersect at -2, 0, and 2. And so in this interval from -2 to 0, I want to figure out which function is on the top versus which function is at the bottom. But then I also want to figure out in the interval from 0 to 2, which function is at the top versus the bottom. So I'm going to take a number in between -2 and 0, and I'm going to plug it into f of x, and I'm going to plug it into g of x to see which number turns out higher and lower. So I just picked -1. I plugged in -1 to f of x, and I plugged in -1 to g of x. And if I did it correctly, you might want to double check my numbers. I got 6 for f and -3 for g. Since 6 is higher, then I know that f is the top function. So then when I go to integrate and find the area in between those 2 curves in that interval, I'm going to integrate from -2 to 0, and then I'm going to make sure I do top minus bottom, which is f minus g. But in the interval from 0 to 2, I also want to test a number in between 0 and 2 in both functions to see which one is higher, because it could change. When I did that, I plugged in 1, I got -8 into f, and 1 in G. And so then I know that 1 is higher than -8. So it looks like G is on the top this time. So then I want to set up a whole nother integral from 0 to 2. And I want to do G of x minus f of x. Top minus bottom now is G minus f. Hopefully once we have it set up, you can go from there. But if you still have questions from there, let me know and I can work out the rest of it. Number 2 is another area problem. It asks us to find the area in between the two curves. So we have an x equals 3 minus y squared. Oh my gosh, sorry. That's John watching the Cardinals game. And then my other equation, if I solve it for x and I move the 1 over, I get a y plus 1. So again, if I'm doing area between two curves, I want to set them equal to each other to find their intersection. So I have my 3 minus y squared equal to my y plus 1. If I move every term to the same side and I factor, I end up getting intersections of -2 and 1. So these two functions only cross or intersect twice. So in those two intersections, hold on, babe. In those two intersection points, I want to figure out who the top minus bottom is. I want to integrate from A to B of top minus bottom. So I'm going to plug in a number in between -2 and 1 into both functions to see which one is higher. If I plug in a 0 into my function, I get a 1. If I plug in a 0 into my other one, I get a 3. So 3 is obviously higher than 1, so that's the one that's going to be on my top. And that is this function right here. That one is on top, this one is on bottom. Okay, and you might want to label them as f and g just so you don't get confused because they have them both as x's. So that helps us fill out our third step, which is integrating from -2 to 1 of my top minus bottom. That was my 3 minus y squared minus my y plus 1, making sure that you distribute that negative through. All right, so hopefully that video helps with the area stuff, and then I'll do another video with the volume, but I'll probably do it a little bit differently so that you can see me, because I like to use my hands when I'm teaching volume so that we can talk about where the axis of symmetry is versus the rectangles. So hopefully that helps. Let me know if you have more questions on those ones, okay?